So we are looking into the worker architecture that kind of sits at the core of the prediction platform. And this is what handles inputs and responses and kind of the flow of every interaction. So we're going to break down how the worker architecture is structured and how its components and fit together. And we'll look at the underlying technology stack all the way through to integration and how you can customize it for your specific environment. So Ramsey, go ahead.
Thanks, Nicola. Appreciate it. Welcome, everyone. Just share my screen so I can stop going to the slideshow. Now I want to just make sure, there we go. Cool. So today we're going to be talking about worker architectures and in particular how they kind of are implemented and used in the ecosystem of AI space. So before we can kind of talk about it, we first need to have an idea of what a worker architecture is. So worker architecture is, in its concept, actually quite simple, but in practice, it's a very complex. If you're using standard archetypes or architectures, it's not a quick fix that you can just add in. It's a complete redesign and restructuring of your whole system. Essentially, the whole practice of it is to try and decouple the actual work that's getting done or in your system from the orchestration. So like how the work gets threaded together. So you kind of want to get into the habit of modularizing and just breaking down all the work into its most core kind of bites of work to make it simple. So you want to have a single work entity that is a very well-designed or well-defined input and a very well-defined output. Something like a very simplistic example would be just a plus operator. You give it two numbers, the first and the second number, and it gives you the sum of the two numbers. That could be a worker if you have some kind of calculator system that you're building. So why do you want to do this? So you can see on the right, essentially what you're going to end up having is your master node, your orchestration node that sits there and you are working with or interacting with the master node. So you're telling it, I want to do this complex thing that's threading together all of these different work chunks. And it understands that these work chunks exist, these kind of bytes of work exist, and it understands how to piece them together, but it doesn't actually know or not able to do the actual work. So at that point, once it starts getting to the point in the execution that it wants to execute a piece of work, it sends that information down to a worker node. So you'll have a bunch of worker nodes, each of them are able to perform a very discrete task. And then once the information is sent to that worker node, it will run it in the background completely asynchronously. So it's not required to finish before the master node can continue, but obviously in certain instances, you will want to wait for the execution to finish before you continue, depending on the particular kind of workflow you have. And once that work gets back, it takes the answer and does whatever it needs to do in the rest of the organization and the orchestration. So what's important to note is that if you just look at this graph, you'll perhaps be inclined to think that these need to be separate servers or separate computers or separate kind of physical work machines. It doesn't need to be. This is a completely kind of theoretical structure. So all of these kind of nodes can sit on the same machine. It's a concept and exercise in virtualization. So you want to make sure that these structures are kind of separated in a sensible way. So which is obvious because I talked about like the master node kind of does the orchestration. It's the part that you interact with. It's the part that knows about the whole concept of what the problem is you're trying to solve. And the worker nodes are very simplistic, dumb systems that know how to do a single thing. So that's essentially, in its most stripped down core concept, what a worker architecture is. It's really straightforward. The problem is if you try to implement this in a already predefined system, it's going to be nearly impossible. You kind of have to build this from the ground up just because the core design is detached or separate from a standard system. So let's look a bit further with how we actually implement this basic architecture idea into our platform. So in our platform, we have the master nodes and the worker nodes spread up into different core conceits. So all the worker nodes that basically are interacted with via API interfaces. So it's an easy way to talk to them, and it sticks to ideas of having a simplistic kind of in and out process. And all the worker node does everything that our platform can do. So like our whole entire structure worker-based, everything that you can do is going to be done through a worker. This is going from data ingestion, data enrichment, prediction models, generative checks, and everything in between. This is not an exhaustive list. This is just a restricted list. And then the question is like, how do you actually get those workers to do anything? So we have multiple ways of doing this. Each of them kind of fulfills a different use case, and they all are kind of aimed at different levels of expertise. So we have our Workbench, which is our kind of graphical user interface for interacting with all of these. Click around, do things, and whenever you get to a point where some work needs to be done, that Workbench just calls to the worker nodes and does the work that's required. Then we have our notebook environment, which is essentially our programmatic environment. So this doesn't have to be done in a notebook environment. You can do this in any programmatic environment you want to, but it allows you to interact with all of these programmatically. We have it built in Python wrappers that allow you to interact cleanly and easily with all of these nodes. Obviously, you can also build your own API connectors from scratch. So we have the wrapper set up, and you can do that. The wrappers are only available in Python at the moment, but it's relatively straightforward to kind of duplicate in any kind of coding environment that you would like. And then you can access all of these workers programmatically. This is our ecosystem agentic environment. You can see it's a very creative name, just taking the ecosystem agentic and smashing it together. And this allows you to kind of connect worker nodes and some specialized nodes, specifically the Kubernetes environment, together in kind of a journey. So whether you want that journey to be a kind of, originally it was designed as a chat environment, a more traditional agentic environment, but as we've gone forward, we've also kind of turned it into pipeline software, so you can kind of do both in the same environment. And then the last kind of masternode area is going to be your runtime front end. It's maybe a bit misleading, the word there, but essentially it's your client or the client's app, the client's website, the client's USSD interface, whatever kind of front end they have to communicate with their customers. That system will then be able to interact with the worker nodes as well. Usually in these kind of productionized environments, they'll only be interacting with the runtime, which is a kind of a specialized worker. That's part of the whole suite of worker nodes, but it's a kind of specialized one that we use particularly for kind of fast real-time scoring. I think we briefly touched on that in the previous meetup, but those of you who were there, apologize for that. So let's look a bit more in depth on it's kind of like working out API infrastructure. I'm assuming at this point that everybody's familiar with APIs. So if you have kind of questions, just raise your hand and I'll try and answer them. Essentially, we use this kind of API structure. You can see it but here on the right, just kind of how that looks in practice. So those are kind of Swagger interfaces that allow you to just like visually see what these interfaces look like. But it gives us the ability to kind of integrate a lot of third-party and proprietary kind of ML libraries, different ML techniques. So we don't see ourselves as a product company. We see ourselves as a company that creates an ecosystem of tools. Being able to pull all those tools together gives you kind of access to the latest and the greatest techniques and kind of software out there to do the most up-to-date ML and AI stuff that you need to do. What makes this also great, why I guess worker architecture is useful, is the workers are completely detached from the orchestration level. So you can add in new things, take out things, change them, and you don't really have to worry about the overarching effects because they're all completely siloed and individualized. So you can just test the individual unit without having to worry about the rest. And it also kind of gives you the flexibility to push out and then develop new things and keep it completely agile. So you have this like environment where you don't set up a big, huge monolith system that's going to keep dragging you down every try to make one update because you have to worry about all the ramifications and all the things that it might affect. And this is not the case here. It's all completely detached and decentralized, which is very great. So this is our kind of core deployment worker. This is the kind of worker that we use to score any models that were trained, run any kind of real-time dynamic models. All of these things all get scored and interacted with through the runtime worker. What makes this great is this thing is completely containerized, and because of the worker architecture, it's completely horizontally scalable. So you can dynamically balance the load if you've got a massive amount of volume coming in, and you know our specifically our worker whose runtime load is going to be benchmarked on 50 interactions per second. Obviously, this is dependent on the kind of case. So if it's a more complex case, your interactions will go down. If it's a more simple case, it will go up. I think the base we've done before is 7 milliseconds per interaction, which will give you roughly like 120 something interactions per second. But 50 is a good kind of middle way, just showing what the actual volume is. But if you now have to handle 200 interactions per second, what you do, you just spin up 4 runtimes, and you can then just have a load balancer sitting on top of that, and you can then handle all the volume you need. Also, why it's useful to kind of have these small independent workers is because they are small and only do what they need to do. They're very low in overhead. So the CPU usage, the memory, all of those things are very low. So it's much more cheaper to spin up multiples of them. And on top of that, the ability to dynamically test, experiment, and deploy new models. If you want to play around, try new things, you can just spin up a new one and play around with it. It's very easy. It's very straightforward. It's built into, it's kind of baked into the core ethos of how you want to work in this environment. So you can always just bring a new thing, create a new worker, and there you go. It's that easy. We talked about kind of the workers, but now we have all the work can get done. Now we need to be able to kind of chain these work nodes together. So how do we do that in ecosystem? So the first thing is the workbench. So I briefly touched on this before, but this is our low code front end. It's getting even lower code in our kind of latest update where we added in a lot of AI assistance in the front that will help you to configure all the things you need to configure, making it a lot easier to kind of get off the ground and running. But this is our UI for managing your AI project. This is where you will come. This will be your landing base. So you can manage, look at, see everything, build new models, enrich data, all of the things that you want to do. What's important to note, like the whole spiel so far has been, is that this workbench, this piece of code has no inherent ability to do any work. It's literally just a master node. It sits there, and then when you click on particular buttons, it will then send a call to the workers to do the work that needs to be done. Even something as simple as just like looking at a table, like that is a worker that's being called to fetch data from a database somewhere and then return it back. And the workbench just has the ability to look at, to know what the call is, and then to visualize the output in a sensible way. I'll just briefly show you what the workbench looks like. I'm not going to go too deep into this since we have lots of other meetups that kind of cover these different aspects of it. But essentially, like I said, now you can see at the front end, you can click on things, go look at something like the predictions. This list that was just generated here, that was a call to a worker. I can click here. If I click any of these buttons now, that'll be a call to a worker. There's actually no inherent ability here. It all sticks to the worker architecture. And another thing that's nice about that is that because the work and the front end is completely detached, you can have your separate worker kind of pool, your front end that's sitting somewhere else. And you can, if you have multiple pools of workers, if you have different areas or servers that are running these workers, you can just point your front end to any of them, and they might have different data attached to it. And then you'll be able to quickly, from the same front end, just link to different ones and get all the benefits of being on that particular environment without having to have a front end that's kind of linked to that environment as well. And the next one that we can look at is the notebooks environment. This is the coding front end. This is where once you're done trying to be low code, you want to get into the nitty gritty of it, want to do everything programmatically. You can start coming in here. Like I said before, this gives you access to all the workers via kind of wrappers. Typically at the moment, we just have wrappers for the Python environment. And you can then do everything that you can do via the workbench, you can do in the notebooks. But you have the freedom to interact with it in more unique and complicated ways because you have the freedom of the programming language. This is going to show you vaguely what that looks like. And what you also note is that our notebooks actually sits in our workbench. So this is kind of having an orchestrator in an orchestrator. I can see basically we have all of these kind of runtimes, all of these packages over here, which are the wrappers that allow you to interact. These are all different kind of workers sitting here, which you can interact with and get them to do particular things that the system is able to do for you. Once again, I think we have had lots of sessions around this as well, so I'm not going to go too deep into that. Then the third kind of way that we have to interact with this is through the ecogentic system, which is our kind of agentic front end. Here, it gets a bit more kind of restricted because you're trying to kind of set up a journey. Like I said previously, this was originally developed as a kind of chat interface, a more traditional kind of agentic, or like a chatbot agentic kind of framework. We moved on from then. So you have kind of this flow, this once again we're using nodes here. So I'm going to overload the term node. But you have this flow going from one node to another, and all of them essentially are workers again. Obviously, since this is roots in a kind of more chatty, interactive framework, we have a lot of specialized nodes set up here that are specific to that kind of approach. So you have like messaging nodes and subscription nodes and things like that. But you also have access to all of the workers that the ecosystem has just via API node. So you just have a particular node that does API calls, and because all of the workers are available through API calls, you can get access to all of the work that you need, that you can do on the ecosystem environment, you can do through the ecogentic environment as well. What's particularly interesting about the ecogentic example is that once you kind of set up your ecogentic environment, or your ecogentic journey rather, you can then essentially utilize that journey as another worker. And you can infinitely stack these. So you can have a journey that at some point as a node that calls another journey, that calls another journey, that calls another journey. You can just like infinitely stack this down, since they all just kind of fit in. The way to call or to interact with the ecogentic journey is just another worker. So it's weird. It's a unique case in the sense that it's both a master node and a worker node. The worker being the interacting with the system, and the master node kind of being the setting up the orchestration of all of the journey underneath the ecosystem, the ecogentic environment. Just to kind of give you a view of what that looks like, you can see essentially I have this long journey of all of these kind of different routes interacting with each other. You can see over here is just, I think this is an API call. Yeah, I can see over here you have like just the message node. But just right click here, you can see all of the specific nodes that are specialized just for the ecogentic environment. But then, like I mentioned before, you have this API node that you can just add in, and this is completely free from API call. So you can just call the worker endpoints and get all the functionality. So if you really want to, you can build a whole API, a whole AI deployment completely through a chat message if that's something you really want to do. And like I said before, also kind of expanding this ecogentic environment to behave more like pipeline software. It kind of have that ability to do both. So then that functionality will be very useful in the pipeline software. You can quickly automate any kind of deployment and setup and kind of data pools that you need for a live productionized AI project. Yeah, and then the final master node that you're going to be looking at is your kind of productionized client's front end. So depending on the client that we're working with, whether it's in the banking space, in the telco space, in the gaming space, whatever, they're going to have some way of communicating or interacting with the customer. So whether that is through an app, through a website, through a widget, through a phone call, through email, or through social media, all of these channels, they will then at some point in the customer journey decide they want to communicate or make a recommendation or utilize the AI or the machine learning in some way. At that point, they just have in their, let's just use the app as an example, and that the ability to then call the API, the worker nodes. In this particular case, it'll, like I said before, most likely be call the runtime, get the prediction back, and then display it in a way that's sensible. So in this case, if you can just use this as an example here, it's like some to the customer for sunglasses, looking to wear for own decor, but the recommender recommended and decided that was for this particular client going to be the ads that will be most likely to influence them or be able to, more likely for them to click. So that is the kind of four main kind of master nodes that we have. Like I said, this is actually a relatively, from a conceptual idea, this is a relatively straightforward concept. In practice, in practicality, how you implement this is going to be a bit more complicated. But we can't really go to in depth around that. So I don't know if there's any questions from the audience around what I just took you through. Any thoughts, any suggestions?
Sorry, maybe a question from my side. Can you guys hear me? Yeah.
Yes, we can.
So from what you've said, has this platform the ability to kind of preempt or apply some preemption to different journeys or different nodes? So, for example, you're running a, say, aggregation model in the background or aggregate predictions, but suddenly there's a front-end task that comes up. Can it slow down sort of the resources that's currently being used by the low priority task, and then kind of speed it up, give priority to a more real-time task, and then kind of switch back intelligently to that? Or is it kind of a bit of a FIFO approach at the moment?
So yeah, like I said, it's completely like asynchronous. So if you're talking now specifically about like how the resources are allocated, that's kind of dependent on your productionized environment. So in theory, you can do it however you like. So generally, when these things get productionized, you'll have your Kubernetes or your OpenShift or whatever your kind of container management softwares that will host these workers, and they will kind of have the resources allocated to them that the client dictates. So if they want to have more resources allocated to them, they will give them more resources or not. If they want to have it dynamically allocated, they can have it dynamically allocated. So we don't dictate that. It's the client that dictates the kind of resource allocation.
Okay, understood. Thank you.
Yeah. So we just set the architecture up in such a way that that is possible to dictate that. You can decide to allocate. You don't stand up one big system that everything is using at the same time. It's all completely detached. So you can have particular resources allocated to particular workers. So if you have a high intensity worker, you can allocate as much resources that is required.
Okay, that makes sense.
Cool. If not, then Nicola, can you just give us an outro?
Thanks, everybody. That was really a great one, Ramsey. I think I'm going to have to go back and watch it a few times to fully compute, so to speak. But yeah, that was great. Thank you. And we will be back here same time, same place in 2 weeks' time. Thank you to everyone who joined.